Okay, so you should have received this orange salmon colored handout, the Pythagorean Theorem. You're going to first cut it in half so that you have two separate pieces. And then where it says cut here along the bottom tabs, that way you'll have a vocabulary tab, solving for C, and then solving for A or B. When you open the first flap, that's going to be your vocabulary. Open up the next flap. You'll have your example 1, example 2, and example 3. Open that last flap and you have example 4, 5, and 6. So if you need to pause while you assemble, that's fine. But we are going to start first with the vocabulary tab. So this unit is all about right triangle trigonometry. So everything we have in this unit has a right triangle. So we have our 90-degree angle. The side that is across from the 90-degree angle, that is called the hypotenuse. The other two sides of our triangle, later on we'll talk about more specific names for them, but for now we're just going to call them the legs. So we have two legs in the hypotenuse. And then we have something called a squared plus b squared is equal to c squared. And that is called the Pythagorean Theorem. Hold on, looks like I'm frozen. We're going to pause a moment. Okay, and we're back. So a squared plus b squared equals c squared. That is called the Pythagorean Theorem. So you'll see we have this picture here of a triangle. And the side on the left, that leg, that is 3 units long. We know that it's 3 units long because we have this square off to the side, and it's 3 units long. The bottom leg, that's 4 units long. We know it's 4 units long because there are 4 boxes along that side. And then the hypotenuse is 5 units long because there's 5 boxes along that leg. So A and B, those are going to be the legs. And the hypotenuse, that's going to be C. So C is always the longest side. So if we take a look at this triangle, one of our legs is 3. We're going to square it. One of our legs is 4. We're going to square it. And that should equal C, and we're going to square it. So 3 squared plus 4 squared is equal to 5 squared. Well, 3 squared, that is 9. So if we look at our box here, we have 9 little boxes. Plus 4 squared, over here we have 16 little boxes. Then the hypotenuse, we have 25 little boxes. And 9 plus 16, that is, in fact, 25. So when this happens, when we do, in fact, have the a squared plus b squared is equal to c squared, and all of our values, a, b, and c, when all of those are nice whole numbers, we call that a Pythagorean triple. And the 3, 4, 5, that's probably the most common Pythagorean triple, the one that we're most aware about. So again, what we've done here is we've got 9, 16, and 25. Okay, so let's go ahead and look at the next tab, solving for C. So example 1. We have our right triangle. We have a vertical side of 5, a horizontal side of 12, and we have a diagonal of C. First thing we want to do is we want to identify that hypotenuse. And the hypotenuse is always across from the right angle. So this is our hypotenuse. Does it matter, 5 or 12, which one you call A and which one you call B? No, it doesn't matter. So we'll just call 5A and 12B. So we have 5 squared plus 12 squared is equal to C squared. 5 squared is 25. 12 squared is 144. That is equal, oh, looks like we froze again. Hold on just a moment. Okay. So 25 plus 144, that's 169. And then to get C not being squared, we're going to take the square root of each side. And we get C is equal to 13. Okay. Now, because all 3 sides of our triangle are those nice whole numbers, we can call 5, 12, and 13. Again, we can call that a Pythagorean triple. Okay, go ahead and pause the video. I'd like for you to try example 2 on your own. So pause the video. So you should get 11.3 for C. Because 11.3 is not a nice whole number, 8, 8, and 11.3, that is not a Pythagorean triple, because we have to do a decimal approximation for this 11.3. That's not an exact answer. All right, so let's take a look at example 3, just a slight word problem. I'm not going to rewrite the word problem. You can look on your own paper. But it says Jane and Zachary start walking at the same point, but Zachary walks 5 feet north while Jane walks 7 feet east. How far apart are Jane and Zachary when they stop? Okay, so they're starting at the same point. Zachary walks 5 feet north, so that means he's going up. Jane, she's going to go 7 feet east, so that's going to the right. How far apart are Zach and Jane? I'm just going to call that X. So again, first thing we want to do is we want to identify that hypotenuse. So we're going to do leg squared plus leg squared equals hypotenuse squared. Five squared is 25. 7 squared is 49. 25 plus 49 is 74. Take the square root of each side, and we get about 8.6 feet is equal to X. And that should make sense, because remember, the hypotenuse is always the longest side. So that hypotenuse, it needs to be bigger than 5 and 7. All right, last page. Let's take a look at example 4. You have a side that's 3, a side that is A, and a side that is 7. So again, identify your hypotenuse. So that hypotenuse, that's going to be isolated on its own side squared. So we know we have to equal 7 squared. The other two sides of our triangles, those are just called legs. Doesn't matter which order we go in, so we'll just say a squared plus 3 squared. Well, a squared is just a squared. 3 squared is 9. And that's equal to 7 squared, which is 49. To get a squared, this one's a little bit different. Now we have to subtract 9 from each side. So a squared is equal to 40. And now we can take the square root. And the square root of 40 is about 6.3. And that answer should make sense, because remember, the hypotenuse is 7. That's the longest side. So the answer that we should get for A needs to be smaller than 7. Okay, again, go ahead and pause the video and work on example 5. And when you're done, restart the video. So you should get B is equal to 24. That makes sense because 25 is the longest side. Also, you should recognize we have 7, 24, and 25. Those are all nice whole numbers. So 7, 24, and 25, that is a Pythagorean triple. Last example. It says Bobby leans a 15-foot ladder against his house. The base of the ladder is placed 4 feet from the base of the house. How far up the house does the ladder reach? There's our house. Okay. We've got this ladder leaning against it. Okay, so here's our house, the vertical side. And we've got some ladder leaning against it. Okay. That ladder is 15 feet. The ladder is 4 feet away from the base of the house. How high up along this side of the house will the ladder reach? Identify your hypotenuse. So this has to equal 15 squared. So the other two sides are the legs. So we have x squared plus 4 squared. Again, we have to subtract in this case. Take the square root of each side. And x is about 14.5 feet. Alright, so we're going to do homework a little bit differently for this unit. For this unit, you're actually going to get a packet. Are we necessarily going to be doing all of these problems? No, but I just want to give you all of the pages at once, so we're not fishing around for them every day. They're already stapled together. What I'd like for you to do for homework tonight is handout 9.4/9.5, number 1. It's the one on the very top. And I only want you to do problems 1, 2, 10, 11, 12, and 13. So these are the only ones that you need to do for tonight. We'll do more problems on this handout another day, and then each day we'll just continue to work, not necessarily on the entire handouts. We'll just take it as we go.